Organizing this competition, and they are the backbone of this competition. Um, Srijit is the president, Ashrae student branch of Maha Dubai. Srijit, wonderful contribution from him and his team. Anand Dhar, Vivian Vincent, Parvati Anil Kumar, Krishna Ajit, Mrunal Pratush. And to guide all these students, Professor Sampath Suranjan has done a commendable job. I would like to appreciate the efforts of Professor Sampath Suranjan and all the student members who have done wonderful job. And participating teams, I wish you all the very best and win this competition and then have great opportunity to participate in CRC competition. Once again, thank you very much. And Mr. Hassan, thank you very much for your opening remarks and nice comments on me. Thank you very much. I'll be in touch. I'll be working for Ashrae definitely wherever I am, and I'm sure that I'll take it to the next level. Thank you. Thank you so much.
Thank you, Dr. Radin.
Thank you, Dr. S.V. Kota, sir, for enlightening us with your great words. Now, I welcome the chairperson of the School of Engineering and IT of Mahe Dubai, Dr. S.K. Pandey, to address the virtual gathering.
Good morning, everyone. First of all, I would like to welcome Mr. Hassan Ali, who is the Ashrae Falcon Chapter President, Dr. Kota Reddy, Academic President, Mahe Dubai, all the other Ashrae members and judges, and my dear students. First of all, thanks to all of you for providing the supports from the Ashrae side and student body to organize such a good events. In School of Engineering and IT, we are very, you can say, that active in terms of professional society activities. But if you ask me, Ashrae is always very active professional body that I have seen. Definitely credit goes to students, but Dr. Kota is always, means as a person, I'll say that whether as an academic president also, he has a lot of responsibility, but always this chapters was very active because of his supports and guidance. And it will be because the way he groomed the people. So I'm quite confident that after that also it will be very active, and especially now Sampath is taking care of that. So thanks, sir, first of all, for that reason. And we got a lot of grants from the Ashrae, and our students have done a lot of projects. And Ashrae side also, we get a very good support in terms of, especially I have seen, definitely I'm not a mechanical person, not background, but the kind of lecture series, the kind of distinguished lectures are coming to the campus, and Ashrae is inviting. I think that is very helpful for the students' body. And especially such kind of event that we are organizing today, always I prefer, whether it's the IEEE or Ashrae, I always encourage such kind of events, because apart from the technical skill as an engineer, the lot of soft skills are required, and this kind of events actually helps a lot to develop that kind of soft skills. One is your idea, but one is that idea you have to present, you have to convince, you have to add business value into that, because we all has to understand idea is important, but at the same time, business values, how it is going to help the society at large. I think those things is very important. So such kind of events really gives you a lot of skills in terms of students, and after getting the feedback, especially from the judges or the committee, I think it helps a lot in future. So I think everybody is mentioning that participation itself, you are a winner. The moment you participate, you are a winner, because you learn a lot. Whether you win the competition or not win the competition, that is the secondary things, because at the end only one person will win, but it doesn't mean that the other person's didn't do a good job. So please continue with such kind of events, and especially during this pandemic, I think the way students are organizing, and again, I would like to thanks to all the student body, because without that it is not possible. And I have seen a lot of last 10-15 days. I'm not saying 10-15 days only, but last 10-15 days you are quite busy to organize this event. Even today the campus is closed also, but you people are there and you are organizing. So thanks to all the student body, the president and the other officials, those who are running, and thanks Sampath for motivating the team. So I will not take much time. Again, I'll hand over to the students to take it further. Thank you.
Thank you, sir, for those kind words. Now, let me introduce the judges for this event. Ashrae Falcon Chapter Chair Secretary, Ms. Meena Ahmed, and President-Elective Ashrae Falcon Chapter, Mr. Mohammad Ibrahim, who will be scoring and marking the participants according to their presentations. I also welcome the professors from School of Engineering and IT, who have spared their valuable time to support this event. Now, I welcome the very reason we are here, our Ashrae student members, who have put in all their efforts and dedication for this event, and the audience who have taken the time to attend this event with us. Before we get into the event, let's run through the event. The RAL student competition consists of a two-stage soft skill competition involving a first chapter level phase and a second one at RAL level during the regular chapter's regional level conferences. The competition is in line with the recent move made by Ashrae, the joint representatives of European Heating and Ventilation Associations, commonly known as REHVA, in their HVAC World Student Competition, during which students are invited to present papers related to heating, ventilation, air conditioning, and refrigeration, and the top performing students are awarded prizes and certificates. Now, let us see the guidelines for this event. The presentation should adhere to the theme of heating, ventilation, air conditioning, and refrigeration industry. The participants can participate as a team or individually. The time allocated is 10 minutes with 5 more minutes to answer questions. Participants must be prepared to answer judges' questions on the content and development of their presentation. Decision made by the jury panel is final. Qualified teams will be presenting in the regional competition. The awards, if any, will be shared among the members. Participants must switch on their camera and present their topic. If any team faces any difficulty in presenting their content, we will be proceeding with the next team, and your slot will be after the next team presents.
Oh, Pratyush, we are not gonna make them any wait longer, but let us all dive into the topic we all were waiting for. I now invite Team Duo to present. Team Duo, you may now share your content. If you face any difficulties in sharing your content, please do update me about this. All the best. But once more, as I told you earlier, we are live streaming on YouTube. If anyone has any trouble during this Teams, please check the link in the chat box and you can see through YouTube. Thank you.
Mrunal, thank you so much for making me the presenter. Now I can share the content.
Parvati and Nafisa, are you there?
Yeah, we are here.
Yes.
Can everyone see the presentation?
Yes, but I just have a quick question. What's your team name? I think they
Now
already
we are
said
a team duo.
Duo. Okay, thank you.
Thank you, ma'am.
First of all, I would like to thank everyone for this wonderful opportunity. So we would like to begin our presentation. So, good morning, ladies and gentlemen. My partner, Parvati Anilkumar, and I, Afisa Shams, would like to welcome you all to the first official RAL Region at Large competition. It is our pleasure to be able to participate in today's competition. So, while taking the current time and situation into consideration, my partner and I have decided to present on the topic Sustainable HVAC Systems in the Healthcare Facilities. So, the main question that arises in our presentation is, why are HVAC systems so important in healthcare facilities?
So, why HVAC system is important in healthcare facility? Now we can have a quick glance to the statistics and data to see how sustainable HVAC system has helped the healthcare facility to improve their efficiencies. So on graph A, we can see the global HVAC system market. So from the year 2018, they have shown a rapid growth as being on the sustainable remarks, and they have been to 2026. It's just an estimation, but we can see now during the situation, what we mainly use is the hospitals and healthcare facilities. So obviously they will have a good rapid growth as the year pass on. On graph B, we can see the global HVAC market from the year 2019.
Okay, so let's look at what are the different types of HVAC and R systems typically used in the market. So first, we have heating and air conditioning split system, which is mainly and more traditionally and commonly used everywhere. Second, hybrid heat split system. Third, duct-free split heating and air conditioning system, which is nothing but your portable air conditioning system. Last but not the least, packaged heating and air conditioning system.
So now we can see where all the HVAC system is implemented in the hospitals. Intensive care unit, operation rooms, airborne infection rooms, protective environmental rooms, compounding pharmacies, etc. So as we are implementing a thermal load in a hospital, the percentage is 79% of HVAC and 21% of other utilities. So why are we implementing system? As we can see in the hospital by a daily basis, so many people are coming. So the microbes and bacteria and other things will be so huge in the hospital. So what we have to do is filtration process to remove the microbes. Filtration is the key to remove the microbes. And the second thing we can do is implementing ultraviolet germicidal irradiation to inactivate the microbes and agents to prevent the we can know the duct is so huge that we cannot get into the duct and clean it on the daily basis. So we can implement the ultraviolet germicidal irradiation to remove the microbes in that. Next is the pressurization of the spaces to clean, to less clean, and to the dirty areas. Temperature and humidity control to reduce the propagation by reducing the deposition of particles to provide a designated path to the exit. Pressurization of the entire building to reduce air infiltration from the outside. Thus, we can keep the healthcare facilities. People, those who are coming to
Okay, so as we learned more information about the HVAC systems, we can now talk about the few of the Ashrae standards for the most important room designs. The first room is the operating rooms. So for an operating room, a proper temperature would be around 18 to 22 degrees Celsius and a relative humidity of 20 to 60%. The operating room ventilation system should produce a minimum of about 20 ACH of MERV 17 and filtered air for thermal control, 20% of which must be outside air. Air should be introduced at the ceiling and exhausted near the floor. Air handling units for operation theaters should be provided with the VFDs to allow for variable speed to cater to HEPA filter loading. HEPA filtered airflow should be dissipated through laminar airflow diffusers. Laminar airflow must be designed to move clean air over the aseptic operating field at a maximum phase velocity of 0.15 to 0.3 meters per second. In general, operating room chilled pipes to the AHU should be designed at a higher velocity of around the range of 1.8 to 2 meters per second to allow for better heat transfer.
So next is the ICUs. Care unit. There are different types of intensive care unit. Surgical intensive care unit, medical intensive care unit, pediatric intensive care unit, cardiac care unit, and neonatal intensive care unit. As we all know, intensive care unit plays a vital role in the hospital because most of the people who are kept in ICUs, some of the people will be in critical condition, some will be having particular conditions. So what we have to implement in ICUs are non-recirculating air HVAC systems. So we can add up reheaters to the systems so that they have a different set. They won't be connected to the other HVAC system, and we can add up thermostat, which should be linked to the BMS system. Last but not the least, the patient rooms. The patient's room should contain a 21 to 24 degrees Celsius and a maximum of 60% of relative humidity with 6 ACHOA and 2 ACHOA. Each patient room should have a different thermostat. And
So, as we have accumulated all the necessary details, we would like to propose a few sustainable ideas now. The first one being for different regions and different countries. So first is for rainy and humid regions. So for rainy and humid regions, we can provide some kind of rain screen or shield on the facades of the building that can aid in moisture control, which will reduce the load on the HVAC systems to dehumidify air, thus saving the energy. Second is for windy regions. If possible, in the windy regions, we can create some kind of wind farm near large, high energy consuming buildings that to provide a source of renewable energy that can be harnessed to power HVAC systems as well as other electrical needs.
so next is the sunny region. As we know, in the sunny region, the sunlight will be so huge. So we can add up solar panels and glass windows, shield windows, so that we can absorb all the energy and convert that to the electricity for running the HVAC system. So as another example is displacement ventilation. We can use displacement ventilation as an alternative method for traditional HVAC system. And this system is economically friendly. So the system works is they cool the air from the outside and it gets pumped into the rooms at low velocity. And by the convection current, it will be warmed up and it will be distributed among the rooms. So the main two key points of the system is they are economically friendly and they don't use duct.
Okay, so how can we actually filter the air in hospitals or healthcare facilities? Where there are a few different steps which we can follow to help filter the air. First one being all air handling units directly serving the space and outside air handling units serving downstream terminal units should be provided with a first stage filtration of no less than MERV 8 and 60% rating, and the final downstream of all wet cooling coils and supply fan according no less than MERV 14 and 70% rating. Second, ultraviolet disinfection, also known as ultraviolet germicidal irradiation, is used to inactivate microorganisms. The third, the use of UVC is encouraged for healthcare projects, especially for cooling coiled surfaces to avoid fungal amplification. The peak effective wavelength, the range for inactivation of microorganisms is around 254 nanometers. The use of upper air UV for patient room in critical care or isolation room is also encouraged to deactivate the spread of the virus.
So that brings us to the end of the presentation. I would like to sum up by saying, for the HVAC, sustainable HVAC system, architecture plays a very, very vital role. If we have a good design and a technology, we can have a good sustainable HVAC system in healthcare. So as we can see, the world earning more of green buildings and green technologies in their building construction. So in the healthcare buildings, which is going under construction or reconstruction, they can implement more of a green building technologies. For a long run, it's good. Setting up way of harness renewable energy for a new or existing buildings. Allow the building should be more clean, eco-friendly and economically friendly for a long run. So these are the references we use for our presentation. I sincerely appreciate your attention today. I would now be interested to know if you have any doubts, thoughts, or questions. And we are so glad that we got a very good opportunity to present in this region a large level competition today. Thank you, Ashrae. Thank you, Manipal. Thank you so much.
Thank you, everybody.
Judges, do we have any questions for them?
Can you hear me?
Yes, sir.
Yes, sir, we can hear.
Yes, thank you. Very, very interesting presentation and nice slideshow. Really good work. And actually, I wish all the competition here, all the competitor here, to reach to the regional level, because that is will be a tough level. You know, you will compete.
Thank you so much, sir.
Countries from Sri Lanka. Welcome. So, countries from Sri Lanka until Nigeria, so that if you take the word from Nigeria, South Africa, until going to the whole Middle East, Jordan, Lebanon, come to GCC countries, and Pakistan, India, and Sri Lanka, Bangladesh, universities across all this region, they will compete in the or competitors from all this region will compete in this regional competitions. This is where I wish to see anyone, all of you there in this competition. So I have one question for you. What is the alternative energy you are advising to use in hospital? Just name the alternative energy that is you think it will be nice with the hospitals to be used.
Sir, the alternative energy, you're asking about the alternative energies, right?
Yeah.
So for example, if it's in the, if you take an example of Middle East, UAE, for example, we know UAE gets really hot during summer. We basically don't even have winter here. So for UAE hospitals, we can put like a lot of solar panels. We can have cooling window screen so that the heat stays inside the hospital and the heat does not go outside, because we know how bad it is for cold air and hot air to mix. So for like we can use like solar panels around the hospitals as well as on the rooftops. And for example, in Asian countries, it gets really rain, like during rainy seasons, it's like flooding basically. So for those, we can have like rainwater harvesting on the roofs of the hospital. We can have some kind of space where we can harvest the rainwater, and then with that energy, we can supply that energy for the HVACR systems.
Excellent. Thank you a lot. I appreciate it.
Thank you so much. Thank you.
Well, there are no questions from my side, but I just want to say thank you for the lovely presentation, and I wish you all the best.
Thank you for
so much, ma'am.
Thank you.
Audience, do we have any questions from audience? Silence means a no, so we will proceed for the on to the next team.
Thank you, Team Duo. Team Origin, don't forget your origin and present well. You're the next team.
Hello, good morning. Can everybody hear me?
Yes, Ruben, we can hear you.
Okay. So good morning, everyone. My name is Ruben DaCosta, and I'm from Team Origin. And we're going to be talking about magnetic refrigeration today. So our team consists of 3 members, which is Anand, Peter, and myself, Ruben. And Peter is going to be talking about the introduction to our project.
Hello, can you hear me? Ruben, would you make it full screen?
Is it on full screen?
So,
Peter, are you speaking?
no, I'm just waiting for it to be full screen. Or is it okay if I start explaining right there?
Yeah, you can start explaining, please.
Okay. Okay, so we'll be starting with the contents. So this is the contents of our presentation. We're going to start with a little bit of introduction, and then we're going to move on to the magnetic calorific effect. We'll be going on to the thermodynamic cycle, magnetocalorific material, comparison, advantages and disadvantages, and conclusion. Next. So I'll be giving you a brief introduction on what magnetic refrigeration is. So basically, magnetic refrigeration is a cooling technology based on the magnetocalorific effect. So this technique can be used to attain extremely low temperatures as well as ranges used in common refrigeration. So the magnetic refrigeration was the first method developed for cooling below about 0.3 kelvins, so which is a temperature attainable by pumping on helium vapors. So now I'll be handing it over to Anand, to Ruben for the next part of the presentation.
Yeah, so I'm going to be talking about the magnetocaloric effect, on which this entire project is based off. So what is the magnetocaloric effect? Simply put, it's known as it's a magnetothermodynamic phenomenon, which means in order to heat transfer to take place, the use of magnets and magnetic field is used. So what it basically means is that temperature change is caused by exposing a magnetocaloric material to a changing magnetic field. So to explain this, I'm going to be showing you a figure and then talk in depth about the entire thermodynamic cycle of this system. So suppose there is a substance, a magnetocaloric material, which is not kept in a magnetic field, which is outside. Now this piece of metal, if this is under the influence of a magnetic field, and then the field is taken away, then the metal cools down. Now, usually, if we apply a cooling fluid to this material, which is inside the magnetic field, it cools down. And then when you take it out of the magnetic field, after cooling it down, it even further cools down. It cools down so much that it can be used as a cooling unit. So this figure right here shows us uh, the like this figure is the first substance right here, which is outside the magnetic field. It has a very high entropy. It has a very high entropy. That means the magnetic moments of this substance is very disordered. Now, when we move it into the magnetic field, that is the first process of our thermodynamic cycle, and it is known as adiabatic magnetization. When it is under the influence of a magnetic field, the magnetic moments go to they align each other in the direction of the magnetic field, and hence the magnetic entropy decreases. When the magnetic entropy decreases, there will be a rise in temperature. The second process is the removal of this heat which has been generated. So usually a cooling fluid like helium or water can be used to remove the heat, and hence after removal of heat, we go into the next process, which is called adiabatic demagnetization. In this process, the magnetic field is taken away, and hence the entropy of the substance increases a lot, and hence the temperature reduces dramatically. And then the last process, which is known as the it's known as isomagnetic entropic transfer. This is when the heat from the load will enter the cool magnetocaloric material right here, which this is the last step where it can be used as a cooling unit. And then this entire process cyclically repeats itself. So this is an overview of the entire thermodynamic cycle. First, the substance which has a lot of entropy, high entropy, it is entering the magnetic field, and it goes from a state of T plus delta T, which is increase in temperature, and low entropy. Then we take the heat away by using a cooling substance, and then we remove the magnetic field, and the temperature of the material even further cools down. Now I'm going to be handing over to Anand. He's going to be talking about the magnetocaloric material itself.
Hello, can you hear me? Hello?
Yes, we can hear you.
Okay. So good morning, I'm Anand. So let's continue with our presentation. Magnetocaloric materials. So we should first understand what magnetocaloric materials are. See, the materials which are used in the magnetic refrigerations are found to have magnetocaloric effect. The best example of magnetocaloric material is gadolinium, which belongs to the lanthanide series, and it's a very rare metal. This material is even used in the MRI machines. Okay. The conditions for the magnetocaloric material is that it should operate in room temperature for the application of air conditioning and 0 degrees Celsius for refrigeration. So now let's move on to the next slide. Okay. So the given table consists of some data of the magnetocaloric materials, which is seen that the gadolinium has the highest Curie temperature of 293 Kelvin. So basically, Curie temperature, like it's a phenomena in which if we heat a magnetic material, it loses its ferromagnetic properties, which means that the magnetic dipoles are freely moving or they are randomized. So the gadolinium material is alloyed with the silicon and germanium to achieve even higher entropy,
as seen in the table. Next slide. Okay, so comparison. So let's now compare the magnetic refrigeration to the conventional refrigeration, which is like the VCR, like the vapor compression refrigeration system, to understand it further. So the main difference between the magnetic refrigeration and the normal VCR is that in magnetic refrigeration, we use magnets, and in VCR, we use the compressor. In the VCR cycle, we compress the gas and then we expand it. But here in magnetic refrigeration, we apply the magnetic field and then remove it. These are the two important parameters, like magnetic field and then pressure in VCR cycle. So as shown in the images, when the magnetocaloric material, it's in the influence of magnetic field, it heats, and when the magnetic field is removed, the material cools down. So it's a different process as compared, but the cycle remains the same. So now let's move on to the advantages and disadvantages, which would be explained by Peter.
So I will be explaining about the advantages of this system. So as you know, for any system, there's going to be a lot of advantages and disadvantages. So let's start with the advantages. The first is the efficiency. So the magnetic refrigeration is highly efficient compared to the Carnot cycle. So the efficiency of magnetic refrigeration is 60 to 70% as compared to the Carnot cycle. And the next one is there are no refrigerants used, so it's more eco-friendly and conserves energy. So as you know, in conventional refrigeration, you use refrigerants like R314A and ammonia, but here you don't use any refrigerants. So they're avoided in the system, so it's more eco-friendly. And this also, it helps in energy conversion, and it reduces the energy costs as well. So the next advantage is that the life cycle cost is much less. So I'll explain what that means. Basically, what it means is initially the purchase. Yes.
Your allocated time has been over, so please stop with the presentation.
Okay. So I'll just quickly just end it.
Yeah, you can conclude it.
Okay. So basically, the conclusion is it's a technology that has been proven to be economically safe. So computer models have shown 25% efficiency improvement on vapor compression systems. So in order to make it commercially viable, scientists need to know how to achieve larger temperature swings and permanent magnets, which can produce strong magnetic fields of 10 Tesla. Then there are also some thermal and magnetic hysteresis problems to be solved for the material that exhibit the magnetic refrigeration to become useful. So thank you for your kind time. So I'll be ending the presentation here.
Judges, do we have any questions?
Yes, actually, I do. So I just want to understand that, actually, first of all, thank you for the presentation. It was very lovely. It's an interesting concept. Is it currently is it being used? Is it applied, or is it just a concept that you're proposing?
It is being, to answer your question, it is being applied, but not in like in a mass production. Like there's no mass production of this particular concept. The main reason is because the availability of the materials, the magnetocaloric materials, which is a key element in this kind of refrigeration systems. So yeah, it's not being used in a majority, but yeah, it is being used.
And in what kind of applications is it being used?
It's mainly for refrigeration in laboratories and stuff.
Okay.
Yeah.
And one last question. You mentioned that you think it's environmentally safe, but is it safe to be around people? Like apart from the environment and the saving of the materials and stuff, the refrigerants, is it safe to be used around like humans? Medically safe, I mean, healthy?
Yeah, it is actually safer to use around people because for starters, there are no leaks from refrigerants, and it's just it's a mechanically simple design. So there's no leaks or there's no any fatal dangers that can be caused to any people around it. So it's very safe.
Okay, thank you. Those were my questions.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, team. This is Muhammad Ibrahim. Thank you a lot. Look like nice idea and innovative. And did you try to apply it, or do you know in any laboratory they try to apply it and to know exactly the efficiency of it, or they done rather than theoretical experience? Do you know any laboratory try to apply this technology and put it effectively, or any university try to apply it as a project from your reading? Thank you a lot.
So it's used like the efficiency, yeah, it's around like 40 to 60%, like which is more than the normal one. And then it's even environment friendly because like normally the VCR cycle, so it actually depletes the ozone layer. Like, it produces around like 300 trillion, sorry if I'm wrong, like which is really like huge for the environment and all. Like it can harm the environment and deplete the ozone layer. But our thing, the magnetic refrigeration, it's actually really good. Like comparatively, it's less. And then 1 minute.
You are muted, Reuben. Unmute yourself.
Oh, sorry. Yeah, so we have no ideas of where exactly it's being used, but then articles and websites have shown that it is being used, but not in majority. So, yeah.
No, I know it has not been used in the majority, but I'm asking if you know any laboratory or university try to apply it or try to make it as a project experiment or graduation project or PhD project to apply it and to put this technology in use. I mean,
we don't know any. We don't know any specific laboratory that uses it, but from the articles that we read, we found out they're used for cryopreservation in medical labs because it attains really low temperatures. So they use it over there, but we don't know if any laboratory university specifically
apply
uses
it or something.
Because it's because it's not commercially used as of now.
It's theoretical stuff. Okay, thank you a lot. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Do we have any questions from the audience? Silence means no. So we will move on to the next team.
Thank you so much.
That was a great presentation. Thank you, Team Origin. Before we move further to the next team, I have a small announcement. All teams should stick to the time allocated, that is 10 minutes. And if you exceed the time, please note that your time will be deducted. Thank you. The next team which is coming up is Team Divergence. Now I request you to present. Thank you and all the best.
Thank you, Mrunal. Thank you for inviting me. So please do let me know if you can see my presentation. Hi, everyone. Good morning to all. I hope everyone is doing just fine. Are you able to see me? Hello?
No, we can only see your screen.
Oh, yeah. I will just fix it. Sorry for the delay, ma'am.
No problem.
Now you can see me, right?
Yes, now we can see.
All right. So I'll be moving on to the presentation. Ma'am, can you tell me if you can see my screen?
Yeah, we can see your screen. And we can see you. You can start.
Okay. Thank you. I'm really glad about being able to do something that is worth a while during this auspicious day. So before I start my presentation, thanks for confirming that you can see my screen and everything. And let me introduce myself first. I'm Srijit Sanalkumar from BTech Mechanical Engineering, a very proud Ashrae Mahi member. So before I start with my topic, I would like to...
Sorry, Srijit, but we can't see you anymore. You blocked the camera with something. Yeah, now we can see you.
Oh, okay, fine. Sorry.
Sorry.
So before I start my topic, I would like to share a small story.
So it's not basically a story, but it's an incident. So as you can see on my next slide here, this is my cute little boy, Balo, and he's my little best friend. I take him for a walk around the house and not outside the boundary of the house due to COVID restrictions during the later hours of the day, and he really loves it. So one day I decided to take him for a walk during the hottest hour of the day. That means noontime. And as you can see in the next slide here, he was jumping around. And if you notice something,
Slide is not moving.
Sorry, sir.
Slide is not moving. You need to turn on the slide.
It's not moving. Oops. I will do one thing. I will share my screen instead of the presentation. Sorry, sir, for the delay. So can you see my presentation now?
Yes, now we can see.
We can
Okay.
see.
I'm sorry for the delay. And by the way, this is Balo. He's my little best friend. So I take him for a walk every evening, and I'm just showing a small short video of him playing around. So as you can, if you notice something here, the tiles laid around my house is made of rock, which means that it can absorb a lot of heat. And if you step on it barefoot, you can get your legs toasted, which is what exactly happened to me and Balo. So my boy was jumping around, and since his foot was on fire, he ran towards the area where the condensed water from one of the outdoor AC unit was being dissipated. First, before starting, I'm going to quickly share the working of a VCR air conditioning system. As we all know, the whole concept has a refrigerant flowing through it, and through the cycle, that evaporator coil, okay, it absorbs the heat from the workspace or the area to be cooled, and the refrigerant absorbs the heat and it proceeds to the compressor system where the refrigerant is being converted to high temperature and high pressure refrigerant, and then this refrigerant flows to the condenser unit where the heat which is being absorbed from the room as well as the heat generated within the compressor is being dissipated, and then it completely becomes in liquid state after passing through the expansion valve. So my area of interest is not actually the air conditioning system but the condenser. I shall suggest why in the upcoming slides. Here is the area we ran to cool down our toasted food, the area we kept as my experimental setup. So I would like to share how the water is being condensed by the air conditioning system. So the quantity of water vapor held in the air is dependent on the temperature. More water vapor can be held at high temperature. As temperature starts falling, the volume of water that can be held in the airborne falls. At dew points, the water vapor will start forming water droplets on the surfaces lower than the temperature. Water formation in the air conditioning unit is shown in this particular figure. The water produced in the internal unit, the water is produced in the internal unit because the evaporator coil is at really low temperature compared to its atmosphere, which is around 45 degrees Celsius. The temperature of the coil surface is very much lower than dew point. And when air is blown onto the evaporator coils, the air cools down and the water starts to condense on the evaporator coils. And this is the water which we are taking as the condensed water. And through a drain pipe, it is being dissipated. So my presentation is adhering to this particular concept. Before I share my concept, I would like to share details on a small experiment I carried out back in my house in India. So my experiment aimed in finding out how much water is being dissipated in 1 hour of operation of this particular AC. So as you can see here, I started my experiment around 1:54 p.m. Indian Standard Time, and I let the air conditioner run for 1 hour. So I switched off the AC at 2:54 a.m. So around this time, as you can see on the adjacent picture, the humidity percentage is around 71%. So what I could find out is I kept a bucket. If you can see in the picture there, I kept a bucket, and it's right below the condensed water tube. So the water is directly falling into the bucket. So after this experiment, what I did is I dipped in a thermometer and found out what's the temperature of water there inside the bucket. It was recorded to be around 15 to 16 degrees Celsius. So, and the amount of water which I collected is around 1.6 liters in an hour. So, I would like to state a relationship here. The amount of water dissipated is directly proportional to the humidity. Hence, I got a convincing result. As you can see, as I suggested earlier, the humidity was around 71%, and it's quite high rate. So I could collect this much amount of water. But we can infer that if the air conditioning system is running for 24 hours a day, we will be able to receive approximately 2 to 20 gallons of water per day. So if in case you're wondering how much is that amount, this one particular bottle which we use for drinking water is approximately 3 to 4 gallons, depending on the size of the bottle. So 2 to 20 means almost many bottles of water, which is being dissipated by the AC. So you might be wondering what's the whole point of me sharing all these experiment details and everything. So I'll be discussing about that shortly. The concept I'll be presenting today is radiant cooling coupled with the normal air conditioning system. So thanks to my boy for making me think about this topic. So I would like to, before I suggest my exact concept, I would like to share what is radiant cooling. A radiant cooling system is a temperature control surface that controls the indoor temperature by removing sensible heat, and when more than half of the heat transfer occurs through thermal radiation. As per the laws of thermodynamics, heat always flows from a region of higher potential to a region of lower potential. So this process of radiant exchange has negligible effect on air temperature, but through the process of convection, the air temperature will be lowered when air comes in contact with the cooled surface. Radiant cooling cools a floor or ceiling by absorbing the heat radiated from the rest of the room. So as you can see in my next slide here, this is a project done by one of our Ashrae member, Anand. He just presented he presented last. The concept is based on radiant cooling. So in this project, the water is being circulated through the copper tubes, which you can see hanging down. So we'll make water circulate through the tubes. And because the water is at lower temperature and the tile is exposed to direct sunlight, it will transfer the heat on the tile to the water. That means the water is being heated up and simultaneously the tile temperature is being lowered. So without any further ado, I'll be speaking on my main point of the presentation. My concept underlies clubbing a conventional air conditioning system with radiant cooling. Here is an AutoCAD drawing I'll be sharing shortly. Here, I connected the outdoor unit of an air conditioning system, to be more precise, the condensed water chamber of the outdoor unit, with a copper tube layout. A negative pressure is created by the pump so that the water can be circulated from the condensed water chamber to the required source. So as the water flows through the pipe, it follows the laws of thermodynamics and heat exchange is happening as the water is at lower temperature reservoir and the room is at higher temperature reservoir. The water which is being circulated through this tube layout can be collected for the desired purpose. We can assume that since the water becomes at a room temperature when it passes through all the room and everything, we can use it for irrigation or any other desired purpose. So through this setup, we'll be able to reduce the load on the conventional air conditioning system, as the room can be maintained at a lower temperature than usual as the radiant cooling is taking place. And hence, when the main air conditioning system is also working simultaneously, the cooling load is significantly reduced around 15 to 30%, depending on amount
Team
of.
divergence, please conclude your presentation first.
Yeah,
Your time is up.
Yeah, I'm about to conclude. So we can expect around 15 to 30% depending on amount of water which is being dissipated by the AC. So as I've suggested earlier, the humidity is directly proportional to the water being dissipated by the AC. So before I wind up, I would like to share that this is a principle I would like to apply on an actual house. And I'm still researching on all possible ways to do the same. Our university is taking part in Solar Decathlon competition, which is due for next year around the same time. And I would like to hear all your feedback and suggestions on this particular concept. And thank you all for patiently waiting for me to complete. I'm open for questions.
Yes, really very interesting idea. Actually, both ideas, starting from the first one to the second one, is interesting. Collecting the condensed water from air conditioning, I think one of the first city they use it as a mass city collection for this condensed water to utilize it is I think in Reem Island in Abu Dhabi. The whole Reem Island, they have their own network for collecting condensing water with the tanks, with sub tanks, and they are utilizing it maybe I think for either irrigation or either in the district cooling plant over there in the PAL technology. Radiant cooling also, it is start to be used a lot in zero energy buildings because it is saving a lot in the energy. What I understand from your presentation here, you took the condensed water from the air conditioning and use it in radiant cooling with and use the condensed water in the radiant cooling, if I'm not wrong. Yeah.
Yeah, that's right, sir. That's right.
Mm-hmm. Okay. Only the last slide here, you need to fix it a lot because you put the VRF outdoor unit and you put the radiant is water, so that you are using.
Sir, actually,
because the VRF is a variable refrigerant flow. You are taking the condensed water and you move it around. So how you will cool the water again?
Sir, we are not recooling the water because maybe the same water we can use it for some other purpose. That's why I didn't plan a recirculating plan, because in a hot region and all, the plants around needs to be irrigated quite frequently as well. So if we connect this pump to a sprinkler system or anything, we can use it for irrigation purpose. That's
So
what
you want to absorb the energy in the condensed water for
Yes,
one
sir.
time while they are going out cold. You want to take them, use them in the radiant cooling, and then use them after that for irrigation or for whatever.
That's right.
Okay.
That's right.
So you want to utilize the energy in this condensed water itself.
Yes, I want to utilize the energy in the condensed water itself. As I suggested in my presentation, the water will be around 15 to 16 degrees Celsius. So maybe when it passes through the whole layout of copper tubes, at the end of the pipe, we might be getting the water, the same water at 24 degrees Celsius or 23 degrees Celsius, because the heat has been already absorbed from the room.
True. The idea is true, and thank you for your presentation. Really smart idea.
Thank you, sir.
Thank you. No more question from my end. Thank you a lot.
Thank you, sir.
I don't have any questions either, but thank you very much, and I wish you the best.
Thank you so much, ma'am. Thank you so much.
Srijit, I just wanted to have one comment. See this, you are using copper tubes. Actually, IIT Bombay has done some research on, I'll give you the details. They used the radiant panel using plastics. So now your idea is good, and then of course the water which is at low temperature, that will be passed through a plastic panel, then which is actually inside the room. okay, such that it can absorb the condensed water will absorb the heat from the room, and the room is cooled, and then that water is getting heated up, and then afterwards we can use for our purpose.
That's
So,
right.
okay, but it's actually IIT Bombay Heat Pump Laboratory, Heat Pump Lab. You can search in the net. You will get some of the ideas. Okay, thank you.
Thank you so much, sir. Thank you so much for the information.
Hello, Srijit. Can you
Hi,
hear me?
hi, sir. Yes, sir. I
I
can
have one
hear you.
question.
Tell me, sir.
Can you tell me how you maintain the temperature consistently?
To maintain the temperature consistently, we need to have a system to cool the water, the condensed water, or we need to make an adiabatic system where the water is being cooled. But here, since the water is being just dissipated freely, like almost for like if you're taking a commercial building, the air conditioning system will be on almost 24/7. So the water is being dissipated continuously. So that's why I didn't include a system where we need to make the water at a constant temperature.
Okay, so what is the expected temperature drop?
Sir, the temperature drop just using the radiant cooling, we can say around 15 degrees Celsius, 10 to 15 degrees Celsius, but it depends on the temperature of water as well.
Okay, thank you.
Thank you, sir. Any more questions? Silence means no, so I guess we'll proceed to the next team.
Thank you, Team Divergence. Team Radiant, it's your turn to conquer the stage. Best of luck.
Can you guys hear me? Hello?
Yes, we can hear you.
Okay. Can you guys see me now? Am I visible?
Yes, yes, you are.
Thank you. Okay. So, good morning to one and all present here. My name is Sahil, and here as Team Radiant, we are presenting on our topic biowalls. So, this is our team. It consists of me, Subiksha, and Vivian. So, today we'll be going through a few contents, which are indoor gases, SBS, that is sick building syndrome, CADR is clean air delivery rate, difference that plants make over conventional and stereotypical air purifiers. And we will compare how potted plants go against biowalls, which are presently in our houses. So, as we know, like we live most of our times in this country, we live majorly inside our homes, right? Like due to high temperatures outside, we tend to stay inside. Like most of our activities happen inside compared to, other countries. So when we stay inside a given space, there are a lot of emissions that we tend to neglect. Like in terms of VOCs, VOCs are volatile organic compounds, which are emitted from various substances like um, disinfectants that we use to clean our floors, aerosol sprays like deodorants, wood preservatives, polished wood can emit a lot of VOCs. Paint, which is all around us, emit a lot of VOCs. So these VOCs can cause a lot of trouble to us as humans, skin irritation, uh, wheezing, and all those kinds of symptoms can be observed in human beings when these play harm in a major way. So another symptom that you will see among people is sick building syndrome. Sick building syndrome is basically in a given space when certain human beings cannot adapt to the surrounding due to all these emissions that are caused. you will see certain symptoms, headaches, blocked nose, dry and itchy skin. And these are a few symptoms that you will see when human beings are in a space and these emissions harm them. So how in our conventional and stereotypical ways we tackle this situation? So these are few air purifiers that you would see very commonly in everyone's house, or not everyone's house, or at least in an office or a given space, you know. But these like they do work to an extent very well, but we don't know how much more better it can get in terms of efficiency. So here we present our concept in terms of biowalls. So I talk about clean air delivery rate. Clean air delivery rate is basically a product of the flow rate of, not the device, sorry, flow rate of air that comes into a space, and the removal efficiency of this air cleaner, given our air purifier in the example I gave you before. So as you can see on the left, air comes in from the outside with outdoor concentrations of various gases, etc., and comes into a space of our indoor space where there are certain emissions again, and these emissions contain all these VOCs, toxins, etc. So that creates a concentration such that when the air cleaner is supposed to clean it, it can depend on how much flow rate comes in. So higher the flow rate and lesser the cleaning means less amount of air is cleaned. Like can you see on the right side, CADR divided by volume. So the rate divided by the volume, if it's lesser than the amount of air coming in, that means the impact will be less. And if the air coming in is lesser than the amount of air the cleaner can clean, the impact will be more. For example, 50 cubic meter of space, an office example. So if 0.2 meter cube per hour of air comes in, so in a given study, 83% of the air can be cleaned by the air cleaner. So similarly, if 1 meter cube of air comes in, 50% can be cleaned. 4 meter cube, which is higher volume of air comes in, 20% will be clean. So higher the rate, lower the efficiency. So now I would like to hand over to Subiksha, and she would be explaining how plants can, help in tackling this situation.
Hello.
Hi.
All right. So thank you, Sahil. I'll be talking about this. Right now, we have discussed about like how exactly we are facing this issue. Why is this VOC a problem to us? Now, to overcome this, we have an organic method. That is how plants can tackle this VOC. So we move on for the next slide. Hello?
I've gone to the next slide. Can you see?
No, mine's not working. Well, okay. So how exactly the plants tackle this VOC? Basically, when the plants have this capability of absorbing the carbon dioxide, and they complete it they make, we have learned it from our lower grades that they convert it as starch and then give it as oxygen back. So this is basically the format which is happening in the plant. But here, if you see, the plants absorb not just the carbon dioxide, but also the VOC components. So whatever that is there in the air, like the aldehydes, the benzene, they are getting absorbed when the plants are absorbing the carbon dioxide. These plants have a capability. If you go to the next slide, these plants have the capability of breaking down these to smaller particles. How exactly? If you see, they have this, they have the chance to absorb it through the leaves, and they get converted in the roots area. The roots have one of the most different features where they can break these microparticles. It could be viruses, it could be not viruses all the time, but it could be also bacteria and so many things which can easily get converted into smaller particles. So they absorb it and they give out the pure oxygen which we need, and then that gets applied throughout the air. Currently, if you see in my own house, we have the potted plants out here. So we are also using the same system so that we have a fresh oxygen supply throughout the place. There's one small study material right now from the presentation. That is like we have these VOCs like formaldehyde, benzene, then we have the trichloro. All these things are being absorbed by the plants, and according to the study, they have completely cleared it out.
So we have like a good supply of oxygen from here, that is 81 to 96%, and then we have 45% of conversion. So all these things are per day by per plant. If this is the case, definitely plants should be recommended in most of our house as not just like a healthy plant, but also as an aesthetic look. Also, it gives a beautiful nature. Yes, the next slide. So now if you discuss how exactly bio walls are helping us. We now know plants are helping us by absorbing it and breaking down the particles. But if you see the bio walls, they have another level of doing it. The structure and construction, it is basically built on a wall. The wall behind me, we can take one entire wall and build it on it. There's this which we are going to provide. And from there, we're going to grow all the plants. And then the water supply. When the water supply is happening, all the things which has to be absorbed is broken down. Down there, you can see there's a small tank-like thing. So where all these things get absorbed and they are there. And then the fresh air goes inside the duct. So all the dirty air in the room, that is all the VOC, all the things which Sahil has discussed earlier, gets absorbed and it goes back to the duct with the fresh air. So if you see. So according to the next slide, this is an example which is there in an office. This can give the proper. Also, we all know that plants are not just something which are there for the healthy purpose, but also psychological wise, if you see, it gives us a positive vibe. Always we have this pressure, stress, a lot of issues. But if you have plants in the wall, like, if you're having those positive fresh air, obviously psychological wise, you get a fresh vibe, you get to think more, and it helps you to work efficiently. The efficiency of the people's work also increases. And also it calms down everybody. And definitely aesthetic wise, it's going to be one of the beautiful ways. And here we see in the first part, it can either be given to the particular room, the office room, or it can be supplied through HVAC to the entire building. So the next slide which we're going to discuss is about the different types of plants. So we have a couple of plants, and these plants are basically in Dubai, in UAE. We are going to use these plants in UAE. The names might be kind of funny, but their way of helping and supporting us is really great. Like lipstick plant, and then we have the dragon plant, and so many things. They absorb a little bit of water, but they're going to help us keep a healthy environment around us. Then the next slide is about the difference between the potted plants and biowalls. Most of us have the potted plants. Most of us have kept the potted plants in the balcony, and now in my house we don't have balcony, so we have kept all the plants in the house. There are so many types of plants, but if you see practically, as Sahil has discussed, lesser the amount of air that gets converted, more the efficiency. But if the air content is more, if the air supply is more, then I'm not sure that how much will we get the proper fresh air outside. So if that's the case, then imagine how many plants can we even keep. So if you see in the potted plants, we can give only a couple, like imagine just minimum of 50 plants can be grown there. So the amount of pots we need, the amount of space it's requiring, it's a lot. But if you see a bio wall, it's entirely on a wall, right? Yes, sir. And
10
yes.
Up. 10 minutes is up. So please do conclude soon.
Sure. So basically in the bio walls are occupying 0.1 meter square. So definitely this is going to be really efficient and recommended for 1 meter square per 100 meter square on the floor. Then the next thing about bio walls and potted plants is that in contrary, so basically negative point. So obviously it's going to cost a lot, and plants die frequently. So you need to replace them. Then pumping the water energy. So we need to also supply water frequently in a day, and also additional lightings. If you don't have a direct sunlight available, this will be also a small problem. That is, the Drexel University is one of the existing bioplants and one of the successful ones. It's a large-scale one and very beneficial for the university. In last, that is conclusion. So we have why do we need basically the bio walls is a question. Here we have it. So basically this main reason is that maintains humidity. There must be a humidity temperature so that we humans feel easier to breathe in air. Then energy saving, and then we have the healthy benefits. We all know plants give us a positive vibe and all. And then we have the sustainability. We are depending upon the sustainable environment, so we have sustainability. And the last thing, improves aesthetics. Thank you. Hope you all like the biowall concept.
Thank you a lot. Interesting idea and healthy and clean. I like the idea really. It is a good one. They use it in many buildings, and it proving to be cleaning the air and giving it. My question: in humid country like UAE, do you think it will be good inside the building or outside the building? Because outside is very humid and it may help. I know several buildings, even in Dubai here, they have the same firewall, and several buildings they put it outside, and in the high polluted city, they love to put it outside so that it will bring the oxygen to inside the building, so that they will use it as a filter to the pollution as well. Anyway, no particular question. Thank you a lot. Interesting presentation.
Thank you, sir.
Thank you, sir. Thank you so much.
The name of your team is Radiant, yeah?
Yes.
Okay, thank you.
So my question was going to be about the disadvantages, but then you mentioned them at the end. So I just want to say it was very comprehensive and very interesting. Thank you very much.
Thank you. Thank you.
Thank you, ma'am.
Do we have any questions from the audience? Silence means no, so we will proceed with the next team.
That was a really innovative and very out of the box creativity. That's what I feel. Thank you so much, Team Radiance, for your presentation. The next team which is coming up is Team Curtin University. The Team Curtin University, you may present now. All the best.
Thank you so much. So, good morning to all the honorable judges, participating teams, and guests, even organizers of today's competition. We are excited to present microcontrollers-based smart energy monitoring system. So, we are Team Curtin Dubai. My name is Kirtana, studying Bachelor of Mechanical Engineering Honors. We have Anwar Ahmed, who's also in his second year of Mechanical Engineering, my fellow team member. So moving on, let's have a brief look at today's agenda of what we will be focusing on. So we'll be talking about a brief introduction and the importance of energy in HVAC. And then we have conducted a literature review on this specific area on monitoring HVAC devices. And then also we would like to speak about why we would need some sort of monitoring system to monitor HVAC systems. And then we'll talk about a focus problem which we discussed, which we chose to discuss, which is the power factor improvement, and also the working mechanism of this particular idea, and also a detailed feasibility study on how this could help us. And also we would like to conclude in the end.
Just a quick comment. We can't see you. So if you're... Okay.
Oh, sorry. Yeah. So, a little introduction about a proposed theme is that we all know that we are many HVAC devices while operation produce electrostatic or magnetic field. When this happens, there's a lot of loss in power, which we don't we don't have access to monitor. So these power losses are called reactive power loss. So it directly affects the performance of the device, because the monitoring devices like meters and power meters in our house, they can only detect the total power of it, but we don't have devices which can actually differentiate between the actual power and the reactive power loss. So it directly affects the performance of the device, because the monitoring device include the power loss. It's hard for these devices to differentiate between which loss is the actual loss, which in turn results in the increased energy power consumption. So our proposed theme focuses on achieving the maximum possibility of energy efficiency in HVAC. So avoiding these losses can be done in different ways, but we chose to use the power factor improvement by adding the capacitor banks to the load side. So this project clearly proposes the demand of having energy monitoring systems in HVAC systems to actually look at the power loss aspect of it. So we have conducted a detailed literature review on this area, and then we have looked at the major milestones from 2013 to 2017 on what development has been done in terms of monitoring systems. And then after this study, we have come to a conclusion that the future scope of monitoring system needs to be needs to take a step where there is zero intervention of humans in the power surveillance. So this is probably the dream of many HVAC engineers and technicians, where there is zero human intervention. Invention of a monitoring system which can carefully monitor energy usage and can instantly help humans to conserve energy is something which we are looking forward at. So these are the articles and the themes we have looked at previously. So the purpose of the project is that we are all moving towards green buildings and home automation and etc. So we many heavy devices like AC, refrigerators, motors, industrial equipment, these some or the other way they need electrostatic or magnetic field during their operation. So what happens is that there is a power loss, and what power loss is that it is essentially that power loss is essentially required for the system to function, but we are finding a way to even compensate the loss to actually bring out the actual power consumption. So we decided to implement a zero human intervention of energy surveillance, which is very ideal for the post-COVID world, because any person can sit in his home and would be able to operate the systems which are essential everywhere in the society. So having such a system which can instantly conserve energy by itself through automation is something which we should look forward to. And this data can be used to monitor remotely via IoT technology. Moving forward, now my team member Anwar will be talking about the concept of power factor improvement. Over to you, Anwar.
Okay, thank you all. So, can you hear me, sir? Hello?
Yes, we can hear you.
Okay. So, before jumping into the mechanism of our system, we think we need to have a clear idea on power factor and how its improvement is done. Because in our project, our main focus will be on it, and everything will be regulated automatically using optimized technologies. The inductors store electrical energy in the form of magnetic energy, and capacitors store electrical energy in the form of electrostatic energy. And furthermore, there is a phase difference between source voltage and current. The cosine of this phase difference is called electrical power factor. Coming to this power triangle, it clearly represents the three kinds of power. Its adjacent represents active power, which is measured in kilowatt, and hypotenuse represents total power, and opposite side of angle shows reactive power. It actually represents the power loss, and it is measured in kilowatt ampere. So after using capacitors, it provides reactive power for inductive load, because this inductive load requires reactive power, and which is these capacitors or capacitor banks will be placed in parallel, and consequently we need to use less amount of kVA to get more useful power, which is measured in kilowatt. So we can understand this reactive power, that means power waste, having a look at the pictures shown in the lower right. They represents our inductive load waveform. So we can see here current is lagging voltage waveform, and the area pictured in red stands for waste before and after power factor correction, more or less respectively. So Kitina will do the other thing.
Thank you, Anwar. So the concept of power factor improvement is quite hectic to understand in just a short span. So we would like to give a practical example of how this works. We have a power supply on the other hand, and we have load right here. It's the same right here with a little change. We'll talk about it. So the total power consumption right here is 100 kVA, but actually the true power which is actually consumed by the load is just 80 kilowatts. But we also need an apparent power to work to operate the system, which is 60 kVR. All right, so we need to figure out a way where we can actually reduce this to 80 kVA because kilowatts, because the power which is being consumed is just 80 kilowatts. So adding a capacitor bank at the load side can actually compensate this issue to just actually where the losses occur can be compensated by a capacitor, because a capacitor is a device which can add the current. So this can be compensated right here. The losses can be compensated, and the 80 kilowatts is just 80 kilo VA because it's just the true power, and the true power has been consumed. So this basically occurs in any HVAC device which produce electrostatic or magnetic field while operation. So how does this concept practically work? So the components which we decided to choose is that a microcontroller. We chose to use Arduino Uno in our project, and then we have a Zigbee, which is a wireless monitoring system which helps the data to be transferred to a IoT module where there is surveillance being done regularly. And then we have relays, 12V adapter, connecting wires, which are the basic devices to put that all into the circuitry. And then we have our a load is the load which we chose is a motor. To bring up this prototype into a small scale, we chose to use a motor. And then we have a transformer, a power supply, and then voltage sensor and current sensor, which are very essential to get the data from the load, and a temporary LCD where we can actually see our power factor values. So moving on. So this is a simple prototype which me and Anwar worked together along with a supervisor. So we have an Arduino board right here. So this is the main component which is programmed to calculate the power factor and also continuously monitor the power factor, the main device. And then we have a load right here. So this is a transformer, a step-down transformer. It step downs to 15 volts along with the bridge rectifier and voltage regulator board. So this power supply is given to this.
Kirtana, 10 minutes is up. Please to conclude soon.
All right. So this is a device which we developed, and the power factor values are monitored, and the voltage sensor and the current sensor gives the values to the Arduino, and this data will be remotely monitored. And then whenever the values, the good part about is that whenever the value is less than 0.85, it gives the operator an alarm and automatically turns on the capacitor bank, which we looked before. So it doesn't need any human surveillance over the system very regularly. And the product is also very feasible because it's generally used manually, but we are getting the automation aspect to it. And then the conclusion of this design is that it needs to be taken care in an initial stage, and then this can be used to many HVAC devices where the problem occurs and the power factor correction can be done. And then we also this keeps the complete industry in synergy, because almost every industry or any even for the home use, there is a need for automation. And then this data can also be used to bring the future scope possible. So these are the references. Thank you for the time, and please feel free to ask us any questions.
Thank you a lot. Really nice presentation, and you took different aspects, the power side of it or the electrical side of it. This is a nice idea, and also you've done a prototype. That is also a good idea, so that it is not only a theory, but you try to implement the theory also. Thank you a lot.
Sir.
Appreciate it. Only I have what is the name of your team first?
It's Team Curtain Dubai, sir.
Team Curtain Dubai. Okay.
Yes.
The only comment that is in your prototype, you put the motor as a DC motor.
Yes, sir.
AC motor, not a DC
Exactly.
motor, because otherwise you will not have reactive power and active power. The
Active
whole
power.
theory is built in AC, not in DC. So that just in your slide there are you put the motor is DC, so that your motor normally is in AC. And yes, in all big plants which we're using as a district cooling, we have a big capacitor banks to solve this issue of the power factors and active power. Again, thank you a lot. Very interesting presentation.
Thank you so much, sir.
That's all from my end.
There are no questions from my side, but I think you have a very good understanding of what you're doing, and it's very creative. So thank you for this presentation.
Thank you. Thank you so much, miss.
Do we have any questions from the audience? Silence means no, so we can proceed with the next team.
Thank you, Team Curtain Dubai. Team Ashrae, you're on stage. Be safe and maintain social distancing.
Hello, am I audible?
Yes. What is your team name, please?
Thank you. Team Ashrae.
Okay. Please go ahead.
Is my screen visible?
Yes, it's visible.
Okay, thank you. Good day, everyone. This is Krishna Ajit from Manipal Academy of Higher Education, Dubai, here before you to present on the topic negative room pressure in hospitals to fight the spread of contagious diseases. Now, before we understand what negative room pressure is or what really negative pressure is, let's have a quick look at the different kinds of isolation facilities provided by healthcare facilities. Isolation facilities helps us to control the airflow inside the room so that the number of airborne infectious particles are reduced to such a great extent that it does not cause any cross-contamination, and it ensures the safety and well-being of all the members in the same healthcare facility. Types of isolation facilities. We have four main types of isolation facilities that are commonly used by healthcare providers. The first one is Class S. Class S is neutral or standard room air pressure with standard air conditioning. The second one is Class P, which is positive room air pressure. In this, immune people are kept inside so they are protected from external contamination. And then we have Class N, which is negative room air pressure. Inside negative room air pressurized cabin, infected individuals are kept and the others are protected. Class N is subdivided into one more type, which is Class Q. Class Q is nothing but negative room air pressure cabin with quarantined isolation. So let's know what negative pressure is. Negative pressure is not the actual pressure or the static pressure which is negative. This can never happen because pressure cannot go below a value of 0. Negative pressure means that the pressure inside a room
is lesser compared to the pressure outside the room, so as to ensure a passive flow of air into the room. In short, negative pressure means that the pressure of a space is lesser compared to another place. This is a relative measurement of pressure. Negative pressure room is also called as airborne infectious isolation room or AIIR. This is a common solution offered by healthcare facilities to hospital-acquired infections. Hospitals use them inside the patient's room so that the germs do not get contaminated and they do not circulate throughout the entire hospital building via the HVAC system. Hospitals design certain environments as negative pressure environments. These are the triage areas. The triage areas are the first contact with emergency rooms. Similarly, emergency rooms are also designed as negative pressure environments. Isolation rooms where the infected persons are kept, bathrooms used by infected people, and areas where the laundry of infected people are washed. Also, autopsy and dark rooms are designed as negative pressure environments. On the other hand, positive pressure rooms constantly has airflow and it helps to sanitize the air which has contaminated germs. These are used in vitro fertilization labs, operation theaters, and animal and child nurseries. Now let's have a quick look at the mechanism of negative room pressure. Negative room pressure is generated and maintained by a ventilation system. In the room, the air flow is through an inlet which is typically kept at the bottom of the door and it is typically 1.5 inch high. And airflow must be only through this inlet. Air must flow inside the room through this inlet. While designing a negative room pressure, one must take into consideration that the room is completely airtight as possible. That is, there should not be any cracks or crevices through light fixtures, electrical outlets, and in and out of the doors and windows. If there are such cracks and crevices, then the negative room pressure will not satisfy its limits. Talking about the exhaust, the air is typically exhausted via the roof of the building. In certain cases, like in biosafety level 4 rooms, the air must be first mechanically filtered or sanitized before it is let out into the surroundings. Monitoring the pressure level. Monitoring the pressure level inside the negative pressure room is an important aspect. There are few methods and two methods are listed here. One is the smoke tissue test and second one is the continuous electronic monitoring. The first method employs smoke and tissue to access the pressurization inside the cabin. A capsule of smoke and tissue is kept near the bottom of the door, and if the tissue is pulled towards the negatively pressurized cabin, it means that the cabin is negatively pressurized. The advantage for this test is that it is cost effective and can be done by anyone, anytime. But it has certain disadvantages. One, it does not give a continuous monitoring. And two, it does not give magnitude on how much pressurized or depressurized the cabin is. So to overcome these, we have one more method, which is the continuous electronic monitoring. In the continuous electronic monitoring, an electric meter is kept, which has isolation ports outside the corridor and pressure ports inside the isolation room. The advantage of this is that it gives a continuous monitoring, and also it sets an alarm whenever the desired pressure goes out of range. Also, these has certain disadvantages like this machinery is costly to purchase and install. This can also only be done by healthcare providers who have safety training and who actually knows to use them. Also, the ports are very sensitive. Hence, if they are contaminated by any particle, it will raise a false alarm, because these are made up of very sensitive electromechanical devices. Now, the additional components to remain effective. Both positive and negative pressure rooms need additional components to remain effective. For a standard sized hospital room, a minimum of 12 airflow change is required each hour to maintain and sustain the negative pressure environment. Also, recirculation of air through HEPA filters, which will control the flow of contaminants, are also used. Self-closing entryways with adequate seals must be placed inside the room. The floors, ceilings, walls, and windows of the room must be thoroughly sealed. And fans and ductwork should be installed in proper way so that there is desired flow of air. A continuous pressure monitoring system which will enable the user to control the pressure should also be used. Thank you.
Thank you a lot. Nice presentation, and really it is a good application. They use it in hospitals, and thank you a lot. I don't have further questions. That's for my end. Midnight is yours.
Thank you.
I also don't have any questions. It was quite comprehensive and very elaborate, so thank you.
Thank you so much.
Do we have any questions from the audience? Silence means no, so
Thank you, Team Safetruck. Well, that was a lot of interesting ideas and concepts. Let us not be overloaded with these many ideas, and hence, let's have a 5 minute break. Exactly 5 minutes. Stay online and enjoy some music. Welcome back, everyone. Let's resume with our presentations. Team Kerbal, please feel free to fill up the virtual space.
Good morning to one and all present over here. My name is Raj. Today, me and my team, we are going to talk about the topic of today we are going to talk about the cooling system in the International Space Station. I would start off with a brief introduction on the International Space Station and why do we need cooling in the ISS. ISS, also known as the International Space Station, is a modular space station in low Earth orbit, orbiting at around 408 kilometers above the mean sea level, and has orbital velocity of 7.66 kilometers per second, or Mach 23, or 23 times the speed of the sound. It completes its orbit every 92 minutes, or about 15 and a half orbits per day. It has been in orbit for nearly 22 years and is one of the most important tools for the scientific community because projects involving zero gravity and exposure to the hostile environments of the space, which are difficult, if not impossible, to create on Earth or simulate on Earth, can be done over there. It has been manned for around 20 years, and right now 3 astronauts are residing in the International Space Station. It has a maximum capacity of 6 astronauts. Now you might be wondering why would we need a cooling system for the International Space Station? Tosif, next slide. So we humans in general are very fragile species. If it gets a little too hot, a little too cold, we would have difficulty in surviving. And the thing with ISS is that when it is facing the sun, it has a temperature of around 121 degrees Celsius. And if it's on the other side, then the temperature plummets to negative 121 degrees Celsius. So to keep the humans inside safe, we require a thermal control system in the International Space Station. Now I would like to hand off the presentation to my friend Adnan, who would be talking about the major thermal control systems used in the ISS.
Hi, my name is Adnan, and I would talk about the major thermal control systems on the ISS. There are two main thermal control systems, passive thermal control system and active thermal control system. The passive thermal control system consists of multi-layer insulation coatings, thermal isolators. Thermal insulation is made. The material used for thermal insulation is mainly aerogel because it is cheap, light, and has very low thermal conductivity. Next, we have the active thermal control system. It uses a mechanically pumped fluid, which is liquid ammonia, to perform three main functions: heat collection, heat transportation, and heat rejection. The heat which is collected is circulated through the large radiators located at the exterior of the space station, releasing the heat by radiation to the space, which cools the ammonia. The next topic will be covered by my friend Tosif.
Am I audible?
Yes,
yeah.
Okay. I will be covering the active thermal control system. Sorry, one sec. Yeah. Used in the International Space Station. Now, this right here is the most. I made this to explain you people the active thermal control system in the most simplest way possible. So the active thermal control system comprises of lots of wiring and pumps used in the spaces throughout the space system. So over here, the heat is collected using cold plate heat exchangers from all the equipments used inside the ISS. As most of the equipments in the ISS produce a lot of heat, which is then transported into the heat transportation, also known as the internal thermal control system, using pump line valves. The coolant used over here is mainly water, and then this is then transported into the heat rejection system, which transfers the heat into the external active thermal control system. I will get there after this. Then the heat is collected in the external active thermal control system, which is then the heat is transferred to the radiators using the pump line valves. Over here, the main coolant is used. The main coolant uses ammonia, as ammonia has a really high thermal capacity. And then this is then transported to the radiators, which are located outside the International Space System. Now, the active thermal control space system has three types of thermal control system, which I'll be talking about. Now, this is the internal active thermal control system. The internal active thermal control system is made to maintain equipments within an allowable temperature range by collecting, transporting, and rejecting the waste heat. This prevents the equipment inside the ISS from overheating and damaging the ISS and the equipments. The active thermal control system uses water because it's an effective thermal transport fluid and safe around the habitable module. Because the astronauts usually mostly live inside the International Space System, and water, being less toxic than ammonia, in case there's a leak, will not harm the astronauts living inside it. The internal active control system uses a closed loop system that provides a constant coolant supply to the equipment, payloads, and avionics to maintain proper temperature. The system on the ISS has two different modules, low temperature loop and moderate temperature loop. The main reason they have these two modules is to provide redundancy in case of failure. Now, the space station is around 400 kilometers in the orbit, so in case of failure, they can't really provide replacements really quickly. So they use two different modules in case of failure of one, so the other one can still function. Now, the low temperature loop is designed to operate 4 degrees Celsius, since some systems like the environmental control and life support require low temperatures. And the moderate temperature loop operates at around 17 degrees for cooling components like payload, and it has 200 liters of water in the loop. Now we'll be going on to the external active thermal control system. Now, this control system resides outside the International Space System. It provides heat rejection capabilities for all the pressurized modules and the main power distribution system. The main power distribution system generates enormous amount of heat, which requires the thermal control system to be outside the International Space System. This space system uses single-phase anhydrous ammonia as its working fluid for high thermal capacity and wide range of operating temperature. Because of the amount of heat produced, the ammonia is a better coolant over here than water. The system uses a single-phase anhydrous ammonia as its working fluid, as its thermal capacity and wide range of operating temperatures. Ammonia has extremely low freezing point of minus 107 degrees Celsius or minus 77 degrees Fahrenheit at standard atmospheric pressure. The external active thermal control system is also comprised of two independent loops. So this again is used for redundancy, and so in case if one loop fail, the other loop can still cool the power system of the International Space Station. Now I will be going on to the photovoltaic thermal control system. This is the most important thermal control system in the International Space Center, as this thermal control system is the one that dumps all the heat into the space. The photovoltaic control system contains of ammonia loop that collects excess heat from the electrical power system, components in the integrated equipment assembly, and transports heat to the PV radiators, which is rejected into space. Here we can see the radiators fully extended. These are the radiators that radiate all the heat into space. Heat is transferred from the orbital replacement unit electronic boxes to the cold plates via fine intervening fins located on both sides of the cold plate and electronic boxes. The Replacement unit electronic boxes are basically certain modules which require a lot of cooling. So they are also located outside the International Space Center. The fins add lateral structural stiffness to the cold plates, in addition to increasing the available transfer area. So to be efficient, the fins itself add structural integrity to the cooling system outside the International Space Center, such as these fins over here. The photovoltaic thermal control system consists of all the pumping capacity, valves, and control required to pump the heat transfer fluid into the heat exchanger and radiator to regulate the temperature of the thermal control system. The radiator is deployable in the orbit and comprised of two separate flow paths through the 7 panels. There are 7 of these radiators located all throughout the Space Center to cool it down. Now, these are our references. And thank you, Ashrae and our teachers. Now, if you have any questions, please feel free to ask.
Yes, actually, I came in about a minute late, so I want to see your introductory slide again to further understand the purpose of your system. Is that okay?
Yeah, sure. So we started off by Raj explaining us about what the ISS is and where it is located. If I may, shall I explain this to you again? So the ISS is basically a modular space center in the low Earth orbit, orbiting around 408 kilometers above the mean sea level at a speed of 7.66 kilometers per second. It completes its orbit every 92 minutes. The ISS provides a platform to conduct scientific experiments, especially those involving zero gravity and exposure to space. So there are many high-level scientific experiments which cannot be performed on Earth. So the ISS provides the equipment and the atmosphere necessary for these experiments to be performed. Next, we moved on to why we require the thermal control system in the ISS. So humans.
Yeah, I was here for this.
Sorry?
I just missed the first one. I was here for this. I just missed the first one. So that's fine. Thank you very much.
Okay.
Thank you, ma'am.
Yes, thank you as well. Really interesting presentation and interesting application for HVAC. What is your team name again?
Kerbal.
Kerbal.
I cannot find. I will add it anyway.
Fourth one from the bottom. Fourth from the bottom.
Fourth from the bottom. Kerbal?
Yes.
Yes, sir.
Okay. From which university?
Manipal, sir.
Manipal University. Okay. Thank you a lot. Thank you. Really interesting presentation.
Thank you, sir.
Thank you so much, sir.
Thank you.
Do we have any questions from the audience? Silence means no, so we'll move on to the next team.
For your amazing presentation. And the next team which is coming up is Team Plasma Tech. All the best, and the stage is all yours.
Good morning to all present here. We as Team Plasma Tech will be explaining on what is bipolar ionization system. I hope I'm audible. Hello.
Yes, please carry on.
Yeah. Okay, thank you. Before we move in detail, let's look at some of the pollutants that are around us. At our homes, we can see a lot of pollutants such as VOCs, dust, pet dander, etc. Now moving on to our own vehicles, we can see benzene from our artificial leathers in the car, foams, carpets, carbon dioxide due to lack of ventilations, xylene from the plastic parts that are there, and methane from the vehicle pollution, that is engines, etc. And at our workplace itself, we can see similar pollutants that are found in our homes, like volatile compounds from monitors, dust, etc. We all know what an air conditioner is. An air conditioner takes air from the space by removing heat and then purifying it and giving us cool air. There are air filters present inside the air conditioner to provide clean air by removing dust and other pollutants. An ionizer sends out negatively charged particles into the air which latch on to pollutants, and due to the weight of these bonds, these pollutants land on the surrounding, clearing our breathing area. Now, what is bipolar ionization system? A bipolar ionization system produces concentrated negative and positive oxygen ions that neutralize airborne pollutions. It's much similar to what sunlight does to the atmosphere. Bipolar ionization system, or BPI, they aim to replicate mountain air quality while removing pollutants such as dust, mold, VOCs, etc. These units can be mounted onto a furnace, air conditioning system, or even at a ductwood, as shown in the figure. Now, these bipolar ionization system units sends out negative ions containing an extra electron and positive ions missing an electron, which results in unstable conditions. In the effort to gain restabilization, these ions seek out particles inside the air, which they latch on, and hence neutralizing these particles. And now let's move into detail on how this technology works. As I've said earlier, these ions latch onto particles, hence making them large and get caught on the filter very easily. The oxygen ion present inside them destroys the cell wall or the cell bond of the viruses, bacteria, hence neutralizing them and helping them and neutralizing their reproduction. That means it doesn't help them to reproduce, hence reducing the virus. And these oxygen ions also remove the VOCs that are present inside, produced from our furnitures and our other materials, etc. These oxygen ions, hence, as I've said earlier, breaks down odorless gases. Now let's move into the benefits of this technology. As I said earlier, it reduces particles in the air. These ions latch on to these toxins and makes them large, hence making it easier for the filter to catch them. As a result, airborne particles are reduced, helping us with less respiratory illnesses and VOC reduction and other cancer-causing formaldehydes, which are produced from our furnitures, wood cabinets, etc. Now let's look into detail on how much reduction does it take place. In this graph, we can see that 86% of dust particle reduction in just 15 minutes, 91% of mold spores in 9 minutes, 95% reduction of bacteria in 60 minutes, and other viruses and VOCs in just 95% of VOCs in 60 minutes. And that is actually a big difference. Further moving on, sanitization of bacteria and virus. This is one of the important features of this bipolar ionization system. As I've said earlier in brief, these positive oxygen ions latch onto the viruses and bacteria, neutralizing their walls and hence destroying them completely. As a result, it removes up to 99.9% bacteria and viruses in the air. Now let's look into detail about this. Here, the first image, we can see the scale of reduction that it takes. That is, according to standard filters, microns from 100 to 10 microns are deducted. HEPA, high efficiency particulate air filters, they take from 100 to 0.3 microns of particles, but bipolar ionization systems take from 100 to 0.01 microns particles with neutralizing them. That is, for instance, COVID-19. The coronavirus is 0.125 microns. This proves that bipolar ionization system can, of course, reduce or neutralize the spread of COVID-19. In the second graph, we can see the ion density. As ion density decreases, so does the air quality. By increasing the quantity of both positive and negative charged small oxygen ions, the air quality is improved. That is, at the inside buildings, like I've shown earlier at the starting 3 slides, at our home, at our vehicles, at our workplace, the ion density is very, very low. So more production of positive and negative ions should be sent out to remove the particles in the air. Then, compared to cities, well, it is obviously a little bit higher. The ion density is a little bit higher and less for ion should be produced. Further moving on to the countrysides, to the rural homes, and at last to the pristine nature environment, that is forest, mountainsides. You don't need this actually. Now all this bring down to the major advantages: eco-friendly and cost-efficient, and controls odors. Controlling odors, we have discussed earlier. These odors from a household or other cleaning products are captured by the ion, oxidized and eliminated. Eco-friendly and cost-efficient. It reduces first cost, reduces HVAC equipment by 25%, cuts outdoor air intake by 75%, decreases ongoing energy usage by 30%, and no additional maintenance. Well, you don't need to change your air conditioning system, your architecture, or any other extra equipment shouldn't be bought to fit this equipment or this unit. You can even cut down the air intake from outside by 75% by reducing the fans or any HVAC equipments. And of course, no maintenance cost is required. And of course, extra filter changings and other maintenance costs can be reduced as well. Now let's move on to the applications. Where do we use it? We can use it at our schools, universities, restaurants, hotels, commercial buildings, at our apartments, villas, hospitals, vehicles, and even in industries. Now for a quick recap. Bipolar ionization system is safe. It's highly effective in removing pollutants such as dust, bacteria, viruses, VOCs, easy to install, energy efficient, and no additional maintenance. Any questions?
Yes. So I'd like to know thank you, this is very interesting. But what are the disadvantages of this? If you're saying that it can solve a problem as big as the current pandemic that we're living, then why do you think no one is using this to stop the spread of COVID, to prevent COVID from spreading, and to solve the whole issue that we're facing in the problem in the world right now?
Well, actually, this is being used everywhere. In UAE itself, it's being used a lot. Almost most of the hospitals in UAE, multi-specialty hospitals in UAE, already use this technology. Universities such as Rochester's Institution of Technology, RIT, is using this technology. Vehicles such as Range Rover, the new Range Rover 2020, is actually using this ionization technology. So actually, this technology is actually in current use, but the disadvantage is that there is no live monitorization system. We cannot in-person monitor any change that is there. We have to bring in equipments to check. There is no, but apps are being developed and it's under process by companies such as Plasma Air, Atmos Tech, and etc.
Okay, so do you think that this has helped in preventing the spread of COVID to a certain extent in certain places around the world where it's being used?
Yes, I feel it is. Well, of course, I guess so.
Okay, thank you.
Thank you, ma'am.
Yeah, thank you. Very interesting presentation. Yes, it is widely used, ionization and ultraviolet. Both of them, they are doing a great job in this cleaning. But the problem that is the virus of COVID-19 itself, it is not, it is spreading more by touching and more direct touching, not by airborne. So that if it was airborne, maybe these technologies could eliminate it to a huge extent. But until now, yeah, it is proving that it is aerosol for certain distance meters and with different quantities. But the main problem with this COVID-19, especially, that is it is by touching and by movement, and not it is airborne. If it was airborne, this is could be one of the major eliminating devices for it.
Yeah.
Thank you. Very nice presentation. And as I said, it is two technologies using in this area, exactly in the duct and in the FCUs. One of them is ultraviolet, of course, plus the HEPA filter. If you are hoping a hospital or clear rooms, you're using HEPA filters, but ultraviolet and ionization plus technologies is widely used to prevent viruses and aerosol bacteria and mold. Thank you a lot. Appreciate it.
Thank you, sir. Any more further questions? I hope not. And thank you all.
All right, judges, I would like to inform something. Team SF, Team Amity, and Sriniti informed that they won't be taking part in this competition. I repeat, Team SF, Team Amity, and Sriniti. Thank you.
The last team, but not the least. The next team which is coming up is Team T-Wop. All the best.
Can you guys hear me?
Yes, loud and clear.
And my presentation is visible, right? So you can see my presentation and my face, is that right?
Yes, we can see the presentation and we can see your video.
All right. So good morning to the panelists and lovely audience. I am Sai Rohit Behra and I'm going to talk about something called as TWAP. If you're wondering what is this TWAP, but then you have to wait till the end of my presentation and engage yourself into my presentation to find your answer. But I promise I will answer at the end. But before that, let me ask you a question. What do you prefer? An old Nokia phone or a smartphone? Definitely a smartphone, isn't it? But why? Because of its integrated features, correct? Well, that's when I thought, why not we make our HVAC system also integrated? But then obviously I don't mean surfing internet using an AC. That's not what I meant, but something else. So while thinking about this, I remember those streets in Meena Bazaar or even Karama, you see water leaking out of air conditioners, right? Observing this happened. An idea is born. So I have started my research. So in my research, I found the first thing what I have started is with the climate, because climate is like the most important thing. And I found out that the most suitable climate for water extraction will be hot and humid. So to find the appropriate place, I just had to look around. UAE is like the perfect place to implement this technology. But I was a bit skeptical about the water consumption levels in UAE. So for this, I'll call my best friend. Hello, Google. What's the water consumption in UAE? So my attention went straight there. The water consumption in UAE is quite high. That's what Google says. So at this point, I have decided that the presentation that's going to follow will be based on United Arab Emirates. So first, let's do some climate analysis. So the vapor content in UAE is around 15 grams per kg of dry air for 70% of the time. And it will be 10 grams per kg of dry air for the rest of the time. So basically, when the temperature is high, that's 35 degrees Celsius and above, we get 15 grams per kg, and we can achieve this from March to November. But we get only 10 grams in December to February because the temperature does not actually cross 25 for most of the time. So the data what is being depicted on your screen has been collected for over 30 years before coming to this conclusion. I also found out that the domestic consumption in UAE is around 174 liters per day, but a tourist consumption is 200 liters. Now a question to audience, where do these tourists go if they come to UAE? Any guesses? No rocket science, a hotel, right? Am I correct? A hotel. So can I say water consumption is higher in a hotel? So I can say this, correct? So instead of making numbers in air, let's actually implement it on a hotel and understand the benefits of it, of the system. So for this, let's consider a medium budget hotel in Abu Dhabi. And our aim is to produce water from the HVAC systems and reuse them back to meet the demand of hotel's water consumption. And this is our vision statement. However, I cannot disclose the name of the hotel because of permission issues and stuff like that. So as we progress, as far as the hotel is concerned, it consists of 20 floors and some common area. And the calculations on screen is pretty basic. And if you add this up, you can get the total cooling power required. That's around 3,600 kilowatts. And the air which is treated is around 3,000 meter cube per minute. So this data, our research people got it from the hotel itself, and the analysis which is going to follow will depend on this data. But what is the target? So the target is the hotel has to be maintained at 20 degrees Celsius and the RH level should be 60% throughout the year. Now to achieve this target, let's have a look at the process. Firstly, the integrated system has to be designed to keep the saturation temperature minimum, like the temperature at which water turns into vapor must be kept minimum. And we make use of a heat exchanger, water air heat exchanger instead of a refrigerant R134A to avoid contaminations like condensation contaminants. To avoid that, we use a water air heat exchanger. And if you see, the component over there is called a condenser, and this unit will circulate chilled water through a condenser, then an evaporator coil cools the air surrounding it to a temperature at which water condenses due to low air temperature. And this water is then passed through a pipe, as you can see it on your screen, to the water purification system to keep the water pure and reduce the risk of bacteria. Because if you think of it, a conventional HVAC system was never designed in a thought of achieving a sterilization of water, correct? But our integrated system will consider these issues. So any component which comes in contact with water will be having certified and corrosion resistant materials. Then this water will undergo ultraviolet irradiation, which uses UV rays that kills microbes in water. So as you can see on your screen, it kills the microbes in that process, and the flow rate of the water should be kept as low as possible to maximize the purification process. So when the process is slow, it's killing more microbes, and when the process is fast, it's ignoring the microbes and the water gets dirty. So the flow rate is a very important factor. And the water which passes through this filtration system will be stored for further applications. Now let's come back to our hotel and see how effective our system is. Before that, let me remind you the parameters, what we require. First thing is atmospheric pressure, which is a constant value. Then we need an air temperature. Then we need relative humidity. So with these parameters, we can find the water condensation rate. So you can use the calculator, which is available on this website, what you see on your screen. So you can impute your data and you can get the water volume per hour. Because in this era, it is important to know how to use the right tools than knowing the manual process. So this is like knowledge sharing to all my fellow engineers in this seminar, in this call. And the idea came from one of my faculties. So I think that is allowed. So you can do it too. Know how to use the right tools. So the volume of water, what you see on the screen is for January month. And as we can see as we progress to see the graphs, you will relate it to at a better extent. So these are my graphs, the water generated in each month. And as we have expected previously, in the month of January, February, and December, the water extraction rate is very low, around 2 to 3 meter cube per day, which isn't bad. I mean, better than creating nothing, right? So, but it's not that effective. I can agree it is not that effective. But during our peak summer, the water is extracted up to 10.2 meter cube per day, which is amazing. About meeting hotels' water demand, we can say that in the month of September, we can reach up to 41% of hotels' water consumption. If you see at an annual rate, a total of 24% can be retrieved, can be saved. Again, here's the thing. The hotel also uses a smart water management system which reduces the demand by 30%. I'm talking about integration again. So a combination of our integrated HVAC system and this smart water system can together save up to 74% at a minimum to a 74% at a maximum to a 54% at a minimum. And I can confidently say this. This technology is a proactive answer to the new green requirements that is taking place in UAE. At the end of this is the end of my concept. So I was really excited about this one, and I pitched it to one of my friend, and he was like, I'm happy with the AC unit what I have at home, and why should I switch? I'm sure some of the audience must be thinking this too. But guys, have a look at this one. Trust me, the fresh water is becoming more scarce and polluted, and the consumption is increasing as the population is increasing. The World Health Organization has predicted that by 2025, 50% of the world population will live in areas with water scarcity. So these preventive steps or extracting resources are required to make a great change. And that's what these people at the Water Project do. It is a charitable organization that provides safe and reliable water sources for drought areas. So we could contribute to their mission by implementing this concept, just the concept what we saw right now. And that's basically TWAP, the Water Project. And these are my references. All the data has been verified from the following papers. And this is the reason what I have my voice today for. So all the work, all the things what I spoke is their work. As a final note, I just want to say, it's your choice, a Nokia phone or a smartphone, a conventional HVAC system or an integrated HVAC system, but choose wisely. Thank you. And any questions?
Hi. Thank you. Yes, I have a question.
Yes.
First of all, lovely concept, lovely visuals, and very clear speech. Thank you very much. But I must ask about the visuals. Did you create these, or are they already for the water project, like they were already existing and you used them? Is this a presentation that you created, I mean?
So the presentation is made by me, but the data I have taken from them. But all these animations, what you see, all the data, pictures, what you see, I have made them, even this one.
Okay.
I got from different articles and I put them together. So I made the presentation like pure work, but the data is them. So I converted the data into a narration and I made it.
And at some point you were showing a video, right? It wasn't the presentation.
Yes, ma'am. This is a YouTube video which is just to support what I'm saying, because if I continue talking about it, maybe audience will get bored. So I thought of showing it.
It's perfect. Yeah, thank you very much. I just wanted to know if you made it or not. It's lovely.
I made it. Thank you.
Yeah, thank you a lot. Really nice presentation with many effective data. Thank you a lot.
Thank you so much, sir.
Do we have any questions from the audience?
So silence means no questions, Rajat.
Rohit.
Yes, sir.
I have one question. Is this
Yes, sir.
technology already existing or like just going to be implemented?
Sir, the research paper, what I have found out, they are trying to implement it. Like as you see, they are taking a hotel in Abu Dhabi, and this data is actually true. They took from a medium base, and they are implementing it, sir. And as Sir told in the presentation in the beginning, Abu Dhabi is actually implementing this technology right now.
Okay. So this will be more beneficial to the Gulf region, right?
Yes, sir, Gulf region, and even in India nowadays, it's quite humid, right? And the water scarcity is a really big problem in India. So this is a perfect thing for India as well.
Is it somewhat related to the helical coil dehumidifier?
I cannot say it's exactly that, but somewhat it is related, sir. The concept is similar. Even to be honest, the concept is very similar to a conventional HVAC system as well. But we're just putting a purification system and we are making slight modifications. That's it, sir.
Thank you so much.
Thank you, sir.
Bye.
Thank you, Team WAP, for your amazing presentation. The presentations showcased by each and every team were splendid and very informative. I'm pretty sure the judges must be having a hard time to evaluate your skills. All the best, and with this, let's have a 5 minutes of break while judges make up their decisions. Yeah.
So we shall continue this event. The judges have shared their responses and it was pretty close with each other. So before we announce the results, I would like to hear a few opinions from the audience side about the event. Would anyone would like to speak or share their responses?
Srijit, can I just go ahead?
Yes, Kirtana, you can speak.
Yes, and just to share that I've been in a similar competition organized by Falcon chapter before, and every time I come here, I take something with me. Like last time when I got to know, I had an amazing insights on different HVAC topics, and this time I did learn something about dynamic presentations and everything. And every time it's a step ahead for me, and I'm looking forward to come again and participate in this competition. And then thanks to the organizing team and as well as and to you and Parvati Srijit, you guys did assist us real well, and thank you so much.
Thank you, Kirtana. You had been constantly supporting us for many events which we had been conducting. So really grateful for that. Thank you so much, Kirtana. So now I would like to invite Ms. Menna Ahmed to share her point of view and announce the runner-up position holders.
Hi, everyone. So first of all, I want to say thank you to all the participating students. It's honestly very refreshing to see students as active as you are. I mean, every time, even last time when this happened, the competition, it's on a weekend or on a holiday, and you're all very keen to still be here and to take the time to present and share information and to, of course, do extensive research before sharing this information, which is honestly very inspiring and very refreshing. I was a student not so long ago, and it's not very common to see students as enthusiastic as you. So thank you very much for your time, for your effort, and hopefully we will keep seeing you in our upcoming events. And I love being here. Hopefully I'll be here every time, and yeah, and I'll keep seeing you. So without further ado, I guess we're gonna announce the winners, right, Srijit?
Yes, ma'am, we can announce the winners.
Okay. So I'm gonna start with the third place. Are you ready for the announcement. Okay, in the third place, we have Team TWAP. Thank you very much, TWAP. I already just mentioned your presentation was lovely, very visual, very clear. I loved it. Thank you very much, and congratulations.
Thank you.
In the second place, we have a tie. It's between Team Drumroll, Divergence, and Team Curtain Dubai. Again, congratulations to both teams. You are both wonderful. All the participating teams are wonderful, so congratulations to all of you. And finally, the first place. This team, the first place team, will be invited to the CRC meeting, to the competition in the CRC meeting. So big congratulations to you, to the team that made it. Another drum roll here. In first place, we have Team Radiant. Congratulations, Team Radiant. I personally thought your presentation was very informative. It was a new idea, very innovative. I loved it, and the other judges loved it as well, and I'm sure the audience and everyone loved it. I'm sure you will do great at the CRC meeting, and we look forward to that. Thank you very much. Mr. Muhammad, if you want to add anything, please go ahead.
Congratulations, and really all your presentation was awesome. All your work is great. Keep it up. I see the standard is moving up and up again here, and I am in a great sure that is you will beat even the region over there. So keep it up to the whole team. Really, all your presentation was awesome. Nice idea, from space to radiant to electrical side to the energy. You cover it all, and the whole world is waiting you for your all this creative idea. It shows a huge dedication from your teacher and university to create a student creative like that, and you're using if the technology and presentation skill also is amazing. I remark a huge improvement in the presentation skills and in the utilization of the softwares, and how you are mixing the YouTube with the presentations with live feed. We brought in Google from there. The whole thing's gone to another level. So thank you all for your participation, and wish you get out something also out from this all presentation, and wish that is the Falcon chapter over here with all the students section. They will be the winner in the CRC, because really all of you deserve the winner. And again, congratulations of
Thank you so much, sir. Thank you really so much. This was a great opportunity for us to take part. And I have no idea how happy I am right now. Thank you so much. Thank you, Ashrae, for giving us an opportunity. Last time we were even competed for the poster competition, and this time it's HVAC. It's a great step for us to gain knowledge through these methods. So thank you so much. And thank you, judges, for staying up for the entire event and helping us out. Thank you so much.
Thank you. Can we hear from the winner team?
Yes, I am from the winner team. Radiance, sir. We are from the team Radiance. Really didn't know that this would actually go up to the first round. Thank you so much, sir.
Excellent, super.
So thank you, judges, for sharing your valuable expertise in your industry. And we are really glad to have you back again after the past event. And also, I would like to devote this whole event to our dear professor, Dr. S.V. Kottareddy, because this will be the last event we are organizing with him. So we are really happy that he had been constantly supporting us for all the events from starting. So we'll be really missing you, sir. So, sir, would you like to speak a few words before we conclude the event?
Yeah, thank you all. It went very well. And first of all, I would like to congratulate the winning team, and then the runner-up and then third place teams. Okay, then as mentioned, the winning team will participate in CRC. and I wish you all the very best for your CRC competition. I'm confident that Ashrae Falcon chapter will win the award in CRC meeting. Okay, then I would like to express my sincere gratitude to Mr. Mohammed Ibrahim and Ms. Menta Ala Ahmad for judging this event. Okay, then actually they have taken out the time from their busy schedule to judge this event. Thank you so much, and I request you to support the student activities in this fashion, and not only this way. I mean, you can come and deliver the lectures also to the students. Okay, then definitely, I mean, I'm confident that you will support all the student activities in UAE. Once again, the students, thank you very much for organizing this event successfully, and great appreciations to Professor Sampath Suranjan, who is behind and running this event. Okay, once again, all the very best for all the teams. Thank you very much.
Thank you so much.
Though you are saying I'm leaving, but I'm not leaving. But anyway, I'll be guiding Professor Sampath Suranjan from India. No problem. And I'll be joining, I'll be part of Ashrae in India. But of course, definitely we'll be in touch. Somewhere I'll be in touch with you people. Okay. Thank you.
Thank you so much, sir.
Thank you.
Let's have a round of applause for all the dedication and efforts the participants have taken. Always remember, winning is something, but participation is everything. You might not win today, but as long as you keep participating, you will definitely win one day. But if you don't participate, you will never win. So always remember, always participate, and never ever give up for anything or anyone.
I would like to take this opportunity to place on record our hearty thanks to Ashrae Falcon Chapter President Mr. Hassan Ali Younes and other Ashrae Falcon Chapter members, our esteemed panel of judges, Ashrae Falcon Chapter Chair Secretary Ms. Meena Ahmed, and President Elective Ashrae Falcon Chapter Mr. Mohammed Ibrahim, faculty advisors of various student branches in UAE, and the participants who showcased a spectacular competition for the perfect logistic support and guidance they have extended to all of us at this RAL competition. I would also like to extend my sincere gratitude to Ashrae Falcon Chapter, Student Activities Committee Chair, as well as the Academic President of Mahe Dubai, Dr. S.V. Kota Reddy, Chairperson of the School of Engineering and IT of Mahe Dubai, Dr. S.K. Pandey, Mechanical Engineering Department Program Director, Dr. Rajiv Selvam, faculties and students for providing and supporting us with the facilities. We have been fortunate enough to be backed by a team of very motivated and dedicated colleagues who know their job and are result oriented. And with that, we have reached the end of the first round of the RAL Competition 2020. We, the hosts, Pratyush and Ronald, thank the chief guests, judges, participants, and the audience for taking the time to participate and attend in this event.
Thank you to all. And with this, we are signing off.
Thank you all. Thank you all.
Thank you all very much for your energy and for your time. Bye.
Yeah.
Thank you.